You're running a 1080p video pipeline and your bill just doubled because you picked the wrong model between Wan and Seedance. That's a real cost difference, and this video tells you exactly which one to pick. Wan is Alibaba's open weights workhorse. Seedance is ByteDance's production speed flagship. The choice comes down to cost and flexibility versus speed and features. Alright, so test 1, cost. At 1080p, one of these APIs charges you 0.20 means per second, and the other charges 0.3766 per second. Run 105-second clips, and that gap turns into real money fast. So if you're generating video at any kind of scale, this number is the first thing you need to nail down. I went through the official pricing sheets for both models, and here's what I found. At 720p, Wan 3.0 runs $0.10 per second, versus Seedance 2.0's 0.1522. A 34% gap at the most common tier. Step up to 1080p and Wan is nearly half the price. The one honest caveat is that Seedance 2.0 Fast at 0.09 per second is the cheapest single option in the whole table, but that's a speed-limited tier, not a quality match. Now, Seedance's Fast variant at 0.19 per second does actually undercut Wan's standard 720p price, so if raw per second cost at the budget tier is your only metric, the gap shrinks. But the moment you step up to 1080p or need consistent quality, Wan's pricing advantage is real and it compounds fast at scale. Wan takes cost and it's not subtle. At 1080p, you're paying nearly twice as much for Seedance at standard quality. Wan also runs Apache 2.0 open weights, so you can self-host on an H100 for roughly 0.42 to 0.50 per 5-second clip, which is a whole other level of cost control that Seedance simply can't match. That puts Wan up 1-0. I only caught that self-hosting number because I've been living inside these model cards and pricing docs long enough to know where the real levers are. Drop a comment if the 1080p cost gap has already hit your budget. Okay, so test 2, output quality. A client asks you to generate a realistic human face in motion, and the result looks like melting wax. That's not a vibe issue, that's a lost client. So which model actually holds up on aesthetics, human fidelity, and physics when you push it through a real benchmark? One of the biggest problems I run into when using AI agents is turning their output into YouTube content I can actually use to market my product. That's why this video is sponsored by Subscriber, a tool that helps business owners connect their AI agents to YouTube and market their products without spending 10 hours every week creating content. You can connect Claude or ChatGPT directly to Subscriber. It then analyzes your business, website, and YouTube channel to help you create SEO-optimized video ideas, scripts, thumbnails, and even complete videos that actually match your brand. What I like most is that every week, Subscriber gives me a list of high-potential video ideas I can immediately execute, and it can even help edit videos for me, with or without my face, including videos like the one you're watching right now. It's easy to get started, and you can try Subscriber for free using the link in the description below. Now back to the video. The VBench scores are on screen right now. On VBench, Seedance 2.0 scores 86.4, and Wan 2.2 scores 86.2, which is a near identical aggregate result. But Seedance claims the top spot in aesthetics, human fidelity, and physics for image to video, categories where the gap is more than a decimal point. Seedance 2.5 also claims around 20% better prompt adherence over 2.0, and Wan 3.0 has no comparable published claim on that axis. The aggregate VBench gap is genuinely tiny, just 0.2 points, so on raw overall quality, these two are basically neck and neck. The real difference shows up in the category breakdowns. Seedance leads where it counts most for commercial work, faces, physics, and visual polish. If you're doing abstract or non-human video, Wan's quality is good enough and the cost savings are massive. Seedance takes output quality because the category leadership in human fidelity and visual polish is real, even if the headline VBench number looks like a tie. I didn't expect the gap to show up in categories rather than the total score, but that's where it lives. That ties the series at 1-1. Test 3, speed. You're running a production pipeline that needs to batch 50 clips before a morning deadline, and your model is still spinning 150 seconds into a single 5-second clip. That's a scheduling disaster. Generation time per clip is the number that decides whether your pipeline is usable or just a demo. When I dug into the benchmark data, Wan 2.2 on Replicate takes roughly 150 seconds for a 5-second 720p clip, and Seedance 2.0 does the same job in about 48 seconds. That's roughly 3 times faster. Seedance's fast variant brings a 5-second 1080p clip down to around 35 seconds. Wan can be optimized on self-hosted infra, but that requires real engineering work and it's not the out-of-the-box experience. The speed gap does narrow if you're willing to do the engineering work on Wan. Baysetin has gotten Wan down to 2.75 seconds per clip with heavy optimization, and Voltage Park cut generation from 187 seconds to 60. So Wan's ceiling is actually fast. But that's not a plug-and-play result, and for most teams, Seedance's out-of-the-box speed advantage is the one that matters. Seedance wins speed, and the out-of-the-box gap of 3 times faster on a standard 720p clip is the kind of difference that changes your pipeline design entirely. That puts Seedance ahead 2-1, so Seedance is faster, and edges Wan on quality, but Wan is cheaper and runs anywhere. The last 2 tests cover ease of use and platform limits, and those are the ones that actually decide which model survives contact with a real production environment. If you've ever hit a rate limit wall mid-batch, the next numbers are the ones you actually care about. Test 4. Ease of use. You want to get a non-technical teammate generating video clips by end of day. No GPU setup, no API docs, just a link. One of these tools has a polished zero-code app with free daily credits built in. The other requires you to spin up your own infrastructure before you generate a single frame. Seedance's Dreamina app is the more polished zero-code entry point, with free daily credits and a cleaner interface than Wan's Wan.video. On the API side, Seedance's task-based model needs fewer required parameters, so integration is genuinely simpler. The flip side is that Wan's Apache 2.0 open weights let you self-host and fully customize, which is a huge deal for developers who want real control, even if it takes more work to set up. This one is pretty close on the API side. Wan's async API isn't dramatically harder to use than Seedance's, and both are well documented. The real gap is the no-code layer in the self-hosting story. Seedance wins for non-technical users and fast integration. Wan wins for developers who want to own the whole stack. Which one wins here kinda depends on who's doing the work. Seedance takes ease of use because Dreamina is a genuinely better zero-code experience, and the managed API is simpler to wire up fast. I expected the self-hosting flexibility to swing this one for Wan, but for most teams who aren't running their own GPU infra, Seedance is just easier on day 1. That puts Seedance up 3-1. Test 5. Platform availability and limits. Your production pipeline hits 30 requests per minute, and the API just starts dropping jobs. That's a concurrency cap problem, and it can kill a launch. Rate limits, reference caps, and where you can actually run the model are what we're looking at here. I ran through both sets of docs to pull this out. Wan 3.0's official API caps at 30 RPM and concurrency 2, while Seedance 2.0 runs 600 RPM and concurrency 10, which is a massive production scale gap. But Wan is available on Alibaba Cloud, Qwen Cloud, Replicate, FAL.ai, and as open weights you can run yourself anywhere, while Seedance is locked to ByteDance's ecosystem and a handful of aggregators. Wan takes platform availability because no other model in this comparison runs on as many clouds and open source platforms, and self-hosting removes every rate limit entirely. The final score is Seedance 3, Wan 2, and Seedance is the overall winner of this head-to-head. Wan wins on cost at every resolution tier, especially at 1080p, where it's nearly half the price of Seedance. Its Apache 2.0 open weights let you self-host on an H100 for around 0.42 to $0.50 per 5-second clip. It runs on more platforms than any other model in this comparison, and its vBench score of 86.2 is basically identical to Seedance's 86.4. Seedance wins on speed, generating a 5-second 720p clip in about 48 seconds versus Wan's 150. It leads in the quality categories that matter most for commercial work: faces, physics, and overall visual polish. Seedance 2.5 supports up to 50 multimodal references versus Wan's 5, and it generates native audio in the same pass. Its API runs at 600 RPM with concurrency 10 for high-volume pipelines. If you're budget-conscious or want to self-host, pick Wan, because at 1080p you're paying nearly twice as much for Seedance and the quality gap is 0.2 vBench points. If you need production-scale speed, native audio, or 50 reference scene control, Seedance is worth every extra cent. One thing that doesn't show up in either pricing page, Wan 3.0's default API concurrency, is capped at 2, and the docs don't flag this prominently. If you're building a batch pipeline and you don't request a limit increase before launch, your jobs will queue silently and your throughput will flatline. Check the dash scope console for the concurrency setting before you go live. Now that you know where Seedance wins on speed and features, you probably want to see how it holds up against Kling. I ran that exact comparison, and it's live right now. Runway Gen 4.5 versus Kling 3.0, which is better, is the next one to watch, and the speed numbers there are going to look very different.